Hey guys, it's AJ from Design the Everything, and I have Project ADD. I've been working on a 3D printed jet engine for like 6 months now, but it turns out that printing a jet engine takes a lot of time and a lot of work and a lot of design time. And while I've been trying to get videos done, it's just hard for me to get them in between work when doing a project this complicated. So I'm going to move on from making a jet engine and go to a rocket engine. Now, at first glance, you may think the rocket engine is just as complex as the jet engine. But unless you're SpaceX or ULA, that's just not true. Most hobby rockets don't even have moving parts, where a jet engine may have dozens. For the jet engine, we went through and talked about every step in the design process and all of the different choices to make that jet engine. So let's do the same thing about the rocket engine. Now, I'm not going to go through it in as much detail as I did last time, but I'm just going to talk about the little things that we're changing. For the jet engine, the original problem statement was to design and build a jet engine primarily with 3D printed parts as a technology and educational demonstrator. Now, all we need to do here is really change the word jet to rocket, and we have our new statement. To design and build a rocket engine primarily with 3D printed parts as a technology and educational demonstrator. With our problem statement, we can move on to how we define success. For the jet, we had 3 criteria. The engine had to be at least 75% 3D printed, it had to be able to run for at least 30 seconds, and it had to provide its own air for combustion. I think we can keep the first one. I don't really know how we could call this a 3D printed rocket if it's not at least 75% 3D printed. The other 2 criteria don't really apply here, so I'm going to replace them. I think the first thing we need to do is look at thrust. For a rocket to be useful as a rocket, it needs to be able to get off the ground. Or in other words, it needs to provide enough thrust to overcome gravity. So that's going to be our first constraint. The thrust of the rocket must be greater than or equal to the weight of the rocket. In math, that means thrust is greater than the mass of the rocket times gravity. Additionally, for us to be able to call this a useful rocket, it needs to not explode. In more technical terms, the rocket needs to expend all of its fuel before a catastrophic failure occurs. Now, if that defines success, let's move on to talking about our constraints. Now, not much has changed from the jet engine. We're still limited by many of the same things. However, I do think we can dump the modularity constraint. With the jet engine, I was assuming that parts of it would survive its usage and wouldn't need to be replaced every time. So it made sense to have it in modules so we weren't wasting print time and materials. With the rocket engine, the rocket runs at a much higher temperature and the chances of any part of this surviving are basically 0. So requiring it to be modular doesn't provide any advantage while adding a significant design burden. I'm also not going to require the use of alcohol as the fuel. The choice of alcohol was to make the jet engine easy to use and test inside without the risk of poisonous fumes or chemicals. And I'm never ever going to run a rocket engine inside my house, so that's not really an issue here. Looking at our unknowns, there's still a bunch of things we don't know. First and foremost is the issue of how well do 3D printed parts hold up under heat and fire. I've seen 3D printed hobby rockets before, and I've seen sugar rocket engines made out of PVC pipe. So at very least, we should be able to 3D print the housing for the rocket engine. Just like with the jet engine, we'll need to do a bunch of incremental tests to fill in any missing knowledge. And as a bonus, we'll learn what questions we should be asking that right now we just don't even know we're supposed to be asking them. We'll probably find a lot more questions as we go, but the ones that right now I know I need to ask is, what do the different nozzle geometries look like? What kind of materials do we need to use and how well do they hold up to fire and heat? And how do we make rocket fuel? Once our full design is finished, we'll have to start testing it. Testing a rocket engine is going to be a lot more difficult than testing the jet engine would have been, partially because of the safety issue, but also because I actually need to measure the thrust of this rocket. Whereas the jet engine, we didn't care about thrust. This one, we have a goal in our criteria, so we have to adjust our tests to it. Once we start testing, we'll just use that data to tweak our design any way we need to for it to meet all of our criteria and optimize performance. I'm super excited about this project, probably more than I was about the jet engine, because I know I'll actually have time to make significant progress in a smaller period of time on this one. Hopefully that means we'll be able to get videos out more often. If you'd like to support me as I go through this process, Please click the Amazon affiliate links down in the description below. I'll get a small percentage of anything you purchase after clicking on one of those links. That'll help me buy tools and materials. I also offer Fusion 360 classes in return for channel donations. If you're interested in that, just send me an email to the email address in the description, and I'll get back to you to set up an appointment. Lastly, if you haven't already, just hit the like button, leave a comment, and subscribe to my channel. That'll boost this video and my other videos in the YouTube algorithm, which will help other people find me. Thank you for watching, and I'll see you next time.